So we've launched SuperCloud Composer's dashboard by logging into SuperCloud Composer. First thing we want to do is navigate to the compute list. So we want to, our use case is to build an operating system on a GPU server. So by clicking on the compute list, we're going to go see if a GPU server is in the resource pool of SuperCloud Composer's Odin framework. So we can simply go ahead and click on the search option and plug in the word GPU and see if we find a GPU within the pool. We do find a GPU within the pool. It's 11.231. So let's go ahead and click on the location code. It shows the front and rear view. It's a 1U GPU server, an Intel-based server. All the physical asset information is here for the server architect. So this is very useful information for collecting intel, for troubleshooting some functions that need to be performed as far as lifecycle management on the server. The buttons on the top here represent each one of the lifecycle management of what we can perform on this server, such as power management. So this was reviewed in an earlier podcast. So let's go ahead and deploy the OS. By deploying the OS, we're going to use the option Fast Deploy. Now, Fast Deploy is an option that we can deploy an operating system in seconds, injecting metadata into the replica or snapshot itself. So we'll go ahead and submit it, and we'll give it a name. The name is a required field, so we'll call it GPU Fast. And then we'll say Next here. We'll assign the master volume from the storage pool. This has been uploaded into our artifacts page or repository, and in there it was represented as a golden image, which is essentially a master volume that is offered to the whole entire servers within the iSCSI pool. So we'll say Next there. And then at this point, we'll go ahead and give it a host name. Again, the host name is going to be GPU Fast, and this is going to be the host name that's been embedded into the operating system or injected into the operating system. We'll go ahead and if we click on all 6 ones, we go ahead and implement password complexity. So we'll go ahead and give it a password of uppercase password, lowercase, and then some special character add in 1, 2, 3. So we've called it password at 1, 2, 3. And then we'll go here. We're not going to basically use this use case, but I could just show you how you can inject metadata such as IP address and static information. So a static IP address, instead of it being DHCP, so you'd give it an IP address, gateway, network mask, DNS 1, 2, and 3. And then if you were dealing with VLANs, we would inject VLAN information as far as a VLAN ID interface, IP address, gateway, and network mask. You would add it. And at that point, it would prompt you through some other metadata you wanted to inject into the build. For our use case, we're just going to simply use DHCP, and then we'll go ahead and change this back to static. Change it back to DHCP and VLAN settings of none. And we'll say Next. Then at this point, it'll provide us with a resource block. This information shows up. Let's review it. Basic information. iSCSI is the iSCSI master volume that we've selected to inject our metadata in. And then this would be the build template information that we created that would be injected into our replica or snapshot. So we're going to go ahead and say allocate and assemble. At that point, it will send a redfish command to our composer upstream to say go ahead and build our operating system. So we can click on the compose node list. So the composed node list is really operating systems that have already been composed, slightly different than the compute list. And again, all the lifecycle management functions are available here on the top. Power management, UID, tag management, deploying operating system, uh, resources that are available based on attaching a JBOF through our CDI option, so on and so forth. So we'll go ahead and click on the option here. We'll see that it's already powered up. We'll look at the system information here. And at this point, once we review the system information, we'll go ahead and stop here, and then we'll open up a IKVM console to that compose node and watch it actually post and perform a iSCSI boot from SAN operation.